Hi, this is Brian with Spacebound DIY. Today I'm going to be going over my Maytag front load dryer to show you all the different components that could be going bad in the back end that would stop your dryer from drying. Now in this case we're going to assume that the blower motor is running, that the drum is actually turning inside, and so we're really just checking all of the electrical components. So for this particular dryer, you can find the model number right here. So I'm looking at a MEDC465HW0. You should have a sticker somewhere there on the inside jamb of your dryer as well to show you exactly what model number it is you're looking for. So when you go to look for parts, you'll want to make sure that you match the part that you're getting to the model number of your dryer. So with that, we're going to need a few tools today. So most dryers are going to use a 1/4-inch nut driver to pull all those screws off the back. You'll need a Phillips tip as well in order to take one part out. If you look here, if you pull off your lint trap, you've got a Phillips here and a Phillips here, and we'll need to get to those later in order to pull the part off. Back to now. And outside of that, just a good pair of needle nose pliers and of course your multimeter to check the readings across each one of your components. So let's head on to the back. Alright, so we're going to use our 1/4-inch nut driver to take all of these screws out. There are 8 on this particular model. 1, 2, 3, 4, 5, 6, 7, and then one hiding under here, 8. This plate right here just covers up where your power cord is actually connected to the dryer. If this is underneath this, you don't need to take this plate off, but as you can see in this case, the back that I need to pull off is underneath this plate, so I need to pull this plate off as well. It goes without saying, but I'm going to say it here anyway, unplug your dryer before you begin this. The power coming through here is high enough to kill you, so absolutely make sure that your dryer is unplugged before you begin. One thing I already did before we started here is I took off the duct work from here. So if you haven't done that yet, you don't necessarily have to. You can kind of shimmy this plate over it. Save yourself the hassle though if you can. Just go ahead and take that off and set that aside. All right, so let's go ahead and start off with these screws. Make sure you don't lose your screws. I've got my silicone mat that I keep my screws on just to keep them from rolling away. Again, these wires back here, this is very high voltage, very dangerous. If you touch it and it's live, it's going to be a real bad day for you. So kind of a pro tip here, if you don't have a 1/4-inch nut driver, sometimes you can use just the tip holder there, and it's the same size. Now, that said, if this tip holder is stripped out at all, then you could end up just stripping out your screws. So I would recommend just use your 1/4-inch nut driver tip if you have one. If you don't have one, it's cheap enough to pick one up to add to your tools. As I pull off the last screw, put a little pressure on here, and grab that screw so it doesn't get away from you. Take this, it should pivot back. Oh, I'll take off all the screws as well. Pivot that back, and then lift up. It should come right off. This wire out of the way, and then we'll set that aside. There's a lot of sharp metal on this. All of these edges are pretty sharp. I've already sliced myself once today, just cleaning this out. If you've not cleaned out the back of your dryer, as most people have not, most of this stuff is probably going to be covered in lint and dust, and you'll have a lot of debris built up down in here. Just really junk and dirt everywhere. About 18,000 house fires a year start as a result of dirty dryers. So while you're in here, take the opportunity, wipe everything down, take your vacuum cleaner, clean everything out, and save yourself a bit of risk if you can. Alright, so what we're going to do here is kind of go through a tour of all the parts, and then we'll start checking each part. Alright, so this particular thermal fuse, it's looking for an exhaust temperature here coming off of the heating coil of about 325 degrees Fahrenheit or less. If it goes over that, it will burn out that fuse, and you'll no longer get any heat through your coil. Down here you have another thermal fuse. This one's going to be looking for 302 degrees or less. And then you have one more thermal fuse right here that's going to be looking for 196 degrees Fahrenheit or less. Now, each one of these fuses, you should be able to easily check using your multimeter. What you're looking for in those is really as close to 0 as possible on the resistance. So we'll go ahead and check those now. So we'll set our multimeter to resistance. Set that aside. All right, we'll start with this one down here. Now again, you want to look for as close to 0 as possible on your resistance. All right, so you can see right there we're at 0.1, so that thermal fuse is reading good. If it was bad, what you would see instead is something closer to infinite. Let me just find something at all that I can touch. Obviously there shouldn't be any kind of conductivity between this fuse and the actual shell of the machine. So you can see there we're reading overload. If this fuse were burnt out, that's what you would be reading. But because the fuse is reading close to 0, that tells you that this fuse is good. Now ideally, to properly test these, you'd want to go ahead and pull off these prongs just to make sure that you don't have any other currency path going on. If you're going to do that, make sure that you use some needle nose pliers so you don't damage the wire. You don't want to pull on just the wire. You want to make sure that you pull on the connector. So go ahead and test that again properly. Got 0.4 ohms, kind of bouncing around a little bit, but very, very low. So we've got a good thermal fuse there. So go ahead and put those back on. All right, so that's that fuse. All right, so let's go ahead and assume that this thermal fuse read as an overload, telling us that the thermal fuse is bad. In that case, we'll just pull those two wires off using our needle nose pliers. And take your 1/4 inch nut driver and pull off that screw. And this will slip right out. Now, while we've got this out, taking a look at it, go ahead and just clean that off. But since this thermal fuse is fine, there's nothing wrong with it, we're going to put it back on. Now, anytime you're going to pull off wires, I would recommend that you mark them or take a photo of the way that the wires are set up before you pull them off, so you put them back on the correct way. So that's going to be the thermal fuse for the exhaust air coming out of the dryer drum. Now if we kind of trace the path of the air, it'll help to understand how these things all work. So your air inlet is here. You're going to draw the air up into here, past this heating coil, and push it into the dryer. You've got a fan down here that is drawing the air out and pushing it down the exhaust. So as the air is drawn in, it's heated, goes into the dryer, dries your laundry, gets pulled down this ductwork and pushed out to the outside of the house. It helps to understand why the different fuses have different temperature calibrations. So the next thing that we're going to check is the coil itself that's inside here. Now if you come over here and look, we've got a few different connections going on. From this connection to this connection right here, this is a thermal fuse. From this connection to this connection, this is actually going to be your coil. Now these have different readings that we're expecting, so we'll go ahead and check those now. Okay, so our heating coil should be reading between 8 and 12 ohms is what we're looking for. So we're still set for resistance. Now again, our heating coil is going to be from here to here. So we'll check that. And there we've got 9.6 ohms, so nicely in that 8 to 12. So our heating coil is good. If it read 0 or 0.2, something along those lines, what you're really looking at then is you most likely have a short. So there's somewhere that there's conductivity where there shouldn't be. You're looking for between 8 and 12 ohms. So again, that's from here to here, and that's actually for the coil. Next, we're going to check across this thermal fuse right here. And we're going to look for something close to 0. And in this case, we're getting exactly 0. So that thermal fuse is right where we want it to be. If it's reading overload or infinite, then that tells you that that fuse is broken, it's open, and it needs to be replaced. All right, so we've checked our coil, we've checked our thermal fuse, we've checked this thermal fuse over here. Let's go ahead and check this thermal fuse up top. So again, like the other thermal fuses, we're looking for something close to 0. Slipped off. And if you take a look at the multimeter here, you see we're setting at exactly 0. So that thermal fuse is also good. If you need to take that one off because it's reading as an overload, then that one right there is very, very simple. You just simply pull off the 1 1/4-inch screw there, pops right off, and you can put your new one back in. So these are all very simple components to change. Now, if all of these things are showing good, and you're still not getting a proper dry on your clothes, or it's not drying at all, the last piece here, the most complicated piece of all of them here, is going to be your actual thermostat. Now the thermostat, this one here, we've got 4 prongs. There's 2 different things that are going on. So you have a bias heater, and that's these 2 thinner wires. And then you've got the main power wires right here. Okay. What this is looking for is an acceptable temperature range, and I don't know what that's exactly calibrated to, but there's a very specific temperature range that it's expecting. Our bias heater is actually going to heat up inside of this thermostat so that it has a typical temperature that it's set at, and it's reading kind of as a difference between that temperature and what you expect it to see. The bias heater should be reading somewhere between 5 and 10 kiloohms, okay? So we're gonna go ahead and touch that. You'll see that we're sitting at 4.811 kiloohms, so just a smidge on the low side, still pretty close to that 5 to 10 kiloohms though, so I'm not too concerned with where we're at there. What you're really looking for is the extremes, either overload or all the way down on the low end, close to 0. That's telling us something's broken. But in this case, we're sitting real close to that 5 kiloohms, so I'm gonna say that we're good on our bias heater. So we'll go ahead and put that back on. All right, now these thicker wires, these should be reading close to 0 because this serves a different function entirely. All right, as you can see here, for our main prongs, we've got a 0.0, so we're doing great there as well. Now, my dryer is running just fine. There's nothing wrong with it, and as you can see, all of our parts have read completely correct so far, so no issues there. The last component that I want to take a look at here is going to be our moisture sensor bars. The moisture sensor bars are inside the drum. It's these 2 bars right here. Now these bars can get buildup on them if you use dryer sheets or fabric softeners. What those are looking for is moisture across the 2 of them. It's a very simple component. The only thing that you need to worry about with this is it clean? Is it broken? Is it visibly damaged? What I would recommend for that, if you are having your clothes come out not entirely dry, or they're coming out overly dry, I would take a soft cloth with some alcohol or some white vinegar and just clean those off, and that should get you back up and running just fine. All right, so to get to the back side of your moisture sensor, we're gonna have to take off this exhaust ductwork right here. So not a lot to it. The biggest pain with this is just not losing your screws. They tend to fall off and get down beneath. You'll need your needle nose pliers to get them back out. So go ahead and do that. So that's 1. That's 2. 3. 4 screws on the back side. Now you can see we've got a nice wiggle here, but it's obviously not going to come out yet. There's still something holding up front. So then swap out to a Phillips, and let's come around front. Pull out our lint trap. We've got 1 screw here, and screw number 2 here. I'll just set those in the lint trap, just so I don't lose them. Now it's going to take 2 hands to do this, so you'll want to lift it up and over the lip down below. It's going to take a little bit of wiggling, finagling, but it will come out. push this forward so we can slip that out. There we go. Now while you've got this out, this is a great opportunity to clean this out. So you can run your arm and a rag right up through it, knock all the dust loose, vacuum it out. It's just one less area that needs to be cleaned. So this is the back side of our moisture sensor. Just like before, very easily pull these wires off, remembering that you've got your green on the left, your yellow on the right. And then to pop that off, it's going to be the same 1/4 inch nut driver that we've used for everything else. So that comes off. You'll notice, give this a push, and it pops right out. I'm not going to let that go, it'll just fall inside the drum, but that's all there is to it, to take that out and replace it. So snap that back in, and go ahead and drive the screw back in so we don't lose it. And that's all it takes to get to that particular component. And plug her back up, and it's good to go. The last thing to look at in here, if your light happens to go out inside the dryer, you pop up in your dryer one day, it's dark, you're used to the light, you most likely just burned out your bulb. To get your bulb out, you'll squeeze these 2 prongs here on the side, and there's your bulb, slips right out. As you can see, my bulb filament is just fine. So I'm going to put that back in, and that's good to go. So that's really it, folks. Besides the blower that you might consider, or of course the drum itself, if your belt is squeaking or something along those lines, that's another concern. But for all of the electrical components, this is really all there is to look for back here. Up top you've got your board, you've got your knobs. Those are another section entirely. But if you're not getting drying, you're most likely looking at one of these components here that we've just checked on today. If everything you've got is working the way it should be, then you should be getting those readings that I showed. If this video has helped you at all, I would appreciate a like, comment, subscribe. If you have a problem that I didn't cover, go ahead and give me a shout through the comments here, and I'll see if I can dig into my dryer and let it be the test bed for how to fix yours. Again, this is Brian. Thank you for watching. Have a great one.